Good morning, OSPAPs. I hope you're faring well in this weather, hot and sticky. You can probably hear my fan in the background. So, looking at Shama's calculations question then, by the silence on WhatsApp, I'm wondering whether, well, it may just be that you're too busy, too hot and bothered to do it, or it may be that you're struggling with it. So I thought I'd make a little video and post you the link. That way you can look it up as and when you want to, which will give you opportunity also to try and solve it yourself, which is always a good way of learning. Now, this is a topic that's actually covered in September's newsletter, and I do think it's a really good example of that kind of question. Let's start by looking at what we're actually being asked. So we've got 500 mils of an infusion bag containing 5% dextrose, and then we need to work out how much 10% potassium chloride to add to create 0.2%. First of all, let's get rid of that bit of information, that's irrelevant. If we look at what the 500 ml infusion bag contains in terms of potassium chloride, it's 0%. If we then look at the other solution that's being used to try and make 0.2%, that is 10%. But we don't know the volume, so we have X amount of 10%. And by adding those two together, we're trying to create 0.2%. Again, we don't know the volume because we don't know how much we're adding, and that's 0.2%. I would change each of these to a amount strength. So 10% means 10 grams in 100 mils, which is the same as 10,000 milligrams in 100 mils, which is the same as 100 milligram in 1 mil. 0.2% means 0.2 grams in 100 mils, which means 200 milligrams in 100 mils, which means 2 milligrams in 1 mil. Right, so we're now going to adopt a technique called the alligation technique. So this is a technique applied when you're mixing two products of different strengths. In this case, one of the starting products is 0%. So with alligation technique, we start off by drawing a grid, which is a 3x3 grid. If it helps to remember it, it looks like a bit like a row of teeth, so alligator teeth. I'm always looking for silly ways of remembering things, especially at my age. And into this grid, we are adding 3 bits of information into the top left and bottom left corners and into the middle row. In the top left corner, we add in the highest strength of our two starting solutions, which is 100 milligram per mil. So highest starting strength in highest corner. In the bottom left corner, we write in the strength of our lowest strength starting solution, which in this case is 0. So lowest strength in lowest corner. And in the middle square, we write in the strength of our final solution, which is 2. What we then do is we subtract, little message coming in from my husband then. We subtract across the diagonals. So we do 100 minus 2 equals 98. And we do the difference between 2 and 0 is 2. That's all well and good, but what do they actually mean? Well, each of those figures relates across the horizontal. Okay, so we divide across the diagonal, but it relates horizontally. And what that tells us is that we need 2 parts of the 100 milligram solution, and we need 98 parts of the 0% solution. If we add those together, that means we have 100 parts in total. So let's look at the 0% solution, because we know the volume that we need of that, and that's 500 mils. So therefore, we know that 500 mils contains 98 parts. So 500 divided by 98 equals 51. So we know that each part contains, 5.1. Told you I'm hot and bothered. And I did write this out, but I haven't got it in front of me. So each part is 5.1 mils. Now we know we need 2 parts of the 100 milligram per mil solution. So we need 2 times 5.1 means we need 10.2 mils of the 10% solution. Now you can double check your answer by adding, so our final volume is the 500 mils plus the 10.2. Our final volume is 510.2, and that is containing 10.2 mils of 10% solution. If you do the maths and double check yourself, then hopefully that works out at 0.2%. So I know I've stumbled a bit there, but I need to get on with other work, so I'm leaving this video complete with flaws for you. Hope it helps. Certainly I think it's a really good question, and I'm planning to give you other examples as we go along.